Thank you all for attending. It's a pleasure being here at the Pediatric Technology Center in Atlanta. So what I'm going to do with you guys today is really talk about our pediatric moonshot, explain the motivation for this, what the moonshot is, the new rocket we built, and then talk a lot about the two big programs we're focused on for this year, the Mercury and the Gemini program. And I'll end with our last big challenge, which is our giant funding challenge that we have. So with that, let me get ourselves started. Maybe it's press down. So let me introduce myself. So I have no medical background whatsoever. I used to say the only thing I knew about medicine was that I knew the difference between the left and right ventricle, because I knew the difference between left and right. And then I said that to a pediatric cardiologist who then said, well, that's just because you talk to people in adult cardiology. There apparently are conditions where it's up and down, not even inverted. Yeah. So I have no medical background. I have a long-term career in commercial software. My last full-time job was working as the first president of Oracle's cloud computing business. I retired from there and actually went back to Stanford and started the first class on cloud computing now 15 years ago. About 6 years ago, a unique student shows up who says, oh, he'd like to meet for breakfast. I went, fine. I'm sitting there. This guy walks in. I'm looking, doesn't look like a regular student. Turns out he has an MD, an MPH, an MBA. He's chief of pediatric cardiology at the Children's Hospital, Orange County. So I'm looking at him going, look, why are you talking to me? I don't know anything about what you know about. And so it turns out, and some of you know who Dr. Anthony Chang is. So Anthony is in town to get a master's degree in bioinformatics because he's watched Jeopardy and seen computers beat humans and thinks that AI, big data, and cloud computing need to meet medicine. So Anthony is my portal into their world. And so I've learned things like, this is actually Anthony's story, that he's providing consulting for a little girl in Myanmar. They want to share the ultrasound image with him. They can't. Later on, she dies. He gets to see the ultrasound, I'm saying months later. And he said, well, I actually could have told them what to do. Bring it a little closer to home. This is actually a friend of mine. This is last year. The kid went in for optional shoulder surgery in Arizona. There were complications. They had CT scanned him. They decided to airlift him into CHLA. The CT scan never made it onto the helicopter. He got there, he actually died later that day. Now, whether the CT scan would have made any difference, none of us know, but it certainly couldn't have hurt, right? Taking out of the world of emergency medicine into, and this is a branch of what is called neuroradiology, there's a condition called focal cortical dysplasia. So there's actually a kid in Florida who has this condition. And it's a brain lesion, which if left untreated, the kid has seizures. And so this kid has had seizures for 12 out of 13 years of his life, 2 to 3 times a day. At night, he wakes up screaming. So you can imagine the implications on the family, the kid, the family, et cetera. He was MRI imaged very early. In fact, if you're seeing these slides, you'll see the MRI images on the left. That little red arrow there is pointing you at a focal cortical dysplasia lesion. Yeah, it's like hard to figure out, right? So he was MRI imaged very early on. They didn't see anything. They started giving him all sorts of drugs, some of them very expensive drugs. None of them were effective. They were actually starting to talk about doing electrical implants. And they re-MRI imaged him actually fairly recently, and they now think he has this condition. The image on the right-hand side is actually an ultrasound image, because if you could locate this lesion, you could surgically remove it. And the kid is cured for life. This is kind of an amazing thing. Now, so there's a good and bad to this. So the good news is There's only 2,500 of these cases per year in the United States. Good news. Bad news, well, that means no pediatric neuroradiologist sees very many of these cases. And so the difficulty of being able to diagnose what I call long-term conditions is out there today in pediatric medicine. We have somebody showing up. Hi, welcome. So you just got here in time. So all of this conspired so that when COVID hit in March of 2020, I'm sitting around thinking, you know, are we going to watch Netflix all day? So I thought maybe we could do something useful. So I grabbed a bunch of engineering people, marketing people that I've worked with throughout the years, and we set ourselves a mission. We call it the Pediatric Moonshot. And what is that? We want to be able to reduce healthcare inequity, lower cost, and improve patient outcomes for kids locally and globally. How? By creating privacy-preserving, real-time applications based on access to data in all 1 million healthcare machines in all 500 children's hospitals in the world. So when I say healthcare machine, just to be clear, I mean all the imaging machines, CT, MRI, ultrasound, X-ray. But I also mean things like blood analyzers and gene sequencers and drug infusion pumps and ventilators, et cetera. Okay, so that's the mission. That's how we think we can accomplish the mission. So as with the original moonshot, we looked around at technology and we said, we really need to build a new rocket. There's nothing out there that can accomplish this mission. And so we engineered what, if I'm talking to my clinical friends, I call it a in-the-building cloud service. Over on the tech side, we use the word edge cloud service. But in essence, it's having cloud servers in the building at the Children's Hospital of Orange County or at Bambino Gesù in Rome, et cetera. So why does the server need to be in the building? Well, the only way you could talk, and I'll just pick on ultrasounds, the only way you can talk to the ultrasound is you have to be on the network with the ultrasound, which means you have to be in the building with the ultrasound. And so you can easily imagine the very first conversations we had with the folks in IT ended with NFW. But we knew this going in. So we heavily engineered around security and privacy. We engineered over 30 security features. One of the core team members has 15 years of privacy law experience. So security and privacy have been core to everything we've designed. So I'll explain the architecture fairly briefly. So just like for those of you who speak AWS, in fact, our internal code name is BWS. So Amazon provides compute and storage services, often called EC2 and S3. We did the same thing. We have compute and storage services at the edge in the building. We have networking services. Obviously, this is where we've done a lot of innovation because that's how it is that it can live on the network with the ultrasound and how it can communicate securely outside the building. Onto this infrastructure, onto this compute and storage, there's a particular kind of application. We call them digital twins. And what they're designed to do is replicate the data in the machine. So an edge server, for you to think about it, is paired one-to-one with the machine. It's about, the servers we use right now are about the size of your hand. And so when I say replicate the data, what do I mean? I mean, well, I can replicate the serial number, what's the last error code it threw out, what's the location of the ultrasound, and then finally what we call the gnomic data. So the actual echocardiogram or the MRI image or the blood analysis. These are all presented inside what we call edge data services, which is a series of APIs that allow you, an application, an authorized application, to access that data, okay? And so the whole design premise is by freeing up the data in the machine, right, you can now build neuroradiology applications, orthopedic applications, or cardiology applications, et cetera, okay? So we're not limiting ourselves purely to, although we're very focused on real-time data. So when I say it's twin to the machine, that means as soon as the machine has an ultrasound image, it's also in the edge server in real time. But also we've twinned offline data sources. So PAC systems, which some of you may be familiar with, is kind of where imaging is stored temporarily, at least in most of the hospitals out there. And then the latter category is EMR, EHR data. Again, we think of this as offline data. Okay, so we did a lot of engineering work in 21. By 22, we said, okay, it's time to go into the world. So 2022, we launched the Vanguard program, which is really to deploy edge zones globally. So today we have 8 edge zones, meaning 8 children's hospitals on 3 continents where we have deployed edge zones. We're about to add Gertrude's Children's in Africa, and we're actually right now in conversations in Singapore. So the purpose was really to prove out that the technology could be global and would function globally, is the purpose of the Vanguard program. Okay, so just to oversimplify this, particularly for my clinical friends, I go, this is a lot like what Apple has done with the phone. So Apple built infrastructure, we call it a phone. They distributed it all around the world. They gave people access to iOS and development tools, which gave you the ability to get the information off the camera, GPS information, accelerometer information, etc. And then told the world, go build apps, right? Instagram, whatever. And so we're very similar. It's just our camera is obviously not a visible light camera. It's an ultrasound or it's a blood analyzer. I already said we actually know GPS information. So the idea is go build applications, right? But, I just wanted to finish with this. We wanted to make sure that you could demonstrate how this all works. So at the end, this is actually almost a year ago we did this. We did real-time image sharing between, so that's a picture of Dr. Anthony Chang with the mask on. His oldest daughter has a congenital heart problem. He brought Emma into the echo lab at Children's of Orange County. That's Dr. Wyatt Lai, who's head of cardiology. He's imaging her 6,000 miles away. That's Dr. Alberto Tosi. And actually her godmother also works at Bambino Gesù, which is one of the largest children's hospitals in Europe, in the Vatican, interestingly enough. And in real time, they got to see Emma's heart. Okay? So, if you follow the analogy of the phone, well, if on the first day, Apple had just introduced, okay, here's a phone, here's a development environment, we'd all looked at it and went, okay, so what? So they had to build apps, right? They built calendar, maps, all these kinds of applications. So we felt we needed to do the same thing. So we launched 2 programs, Mercury, which I'm going to talk about, which is really how do you share images from non-children's hospitals or clinics with experts in the children's hospitals. And Gemini is, there are not enough experts out there. Can we build AI, right? Pediatric cardiology AI, orthopedic AI. And so Gemini is a lab, a research lab, to build AI applications for children's medicine. So let me start with Mercury. So we, for fairly obvious reasons, because of Anthony being a cardiologist, we spent a lot of time with cardiology in the early days. But towards the end of last year, we met up with a group called the Pediatric Pandemic Network. So this is HRSA, HHS funded. Basically, the idea is that the children's hospitals have expertise, they are hubs, and that they can share this with spokes, meaning non-children's hospitals, in an emergency situation, okay, pandemic. So for the first time, we started meeting people working in emergency medicine at Texas Children's, at Nationwide, at UCSF, and we started hearing a fairly common theme. Well, this has been Choi, right? It's so difficult to share, to be able to see the image of a kid in the emergency room that, as he says, we're hoping they actually took a photo on their iPhone that we could see, right? This is Amir, who runs trauma at CHLA, because one of the implications when you cannot share this is the kid rolls in the ER, they re-CT them, they re-X-ray them, which means it's more radiation, which is no good. Obviously, think about it, it's also wasting a lot of time in the whole cycle. And so I'm talking to, this is Chris Newton, who runs trauma at UCSF. And I said, Chris, this problem's solved, isn't it? Sharing images, you know, Ombra Health, Life Image, ProShare, I mean, all these things out there. And he said, yeah, except it's so complicated that we actually have to send training teams out to teach them how to use this stuff. It is not simple nor automatic. This direct quote of him. And if you, just for you to imagine this, a lot of this technology that has been used was all developed like 10, 15 years ago. So you can imagine it's Windows, lots of pull down menus. So not easy to use would probably be an understatement, right? So we sat back and went, well, this isn't that hard. Why don't we, I mean, you know, people know how to share photos of their dogs and cats on Instagram. It's not a whole lot different. So we're engineering a fairly simple application. Let me just tell you the story of Howard Memorial. It's good to do this. So as I said, we talked to a lot of people at the children's hospitals, right? But we had never until a couple of weeks ago talked to people at the sending hospital, the non-children's hospital. And so one of the hospitals that sends kids to UCSF is Howard Memorial. So I said, we want to go talk to them. So finally, a week and a half ago, we talked to them, right? And it was like, whoa. So let me tell you their story. Howard Memorial is a non-children's hospital located in Willits, California, population 4969, so 5,000 people live there. When they have a trauma situation with a child, they will send them to either UCSF, Stanford Children's, UC Davis, or if it's a burn situation, to Shriners Burn Unit in Sacramento. Because it is so complicated to use any of this software to answer for this, they actually send CD-ROMs to this very day. And through a quirk, which I'm like, I don't know why they do this. Apparently, when the kid is, and we'll use helicopter as the example of this, put on the helicopter, there are two pouches, one for the patient record and one for the image. And so oftentimes, I suppose in the heat of the moment, they forget the second pouch. And so the kid arrives, no CD, back to, oh, they're going to have to be re-imaged. Actually, people on staff there told us they've actually driven CD-ROMs from Northern California down to San Francisco, 3.5 hours, right? Okay. So we're looking at this going, this isn't that complicated. So this is the application. So we're thinking about this, just to make you think about another example. In Texas, they have these things called standalone EDs, emergency departments. So these are in shopping centers. Right? There's 250 of them in Texas. So when we imagine how this stuff is being used, it's not, we're trying to imagine some big children's hospital Atlanta situation. No, there's an X-ray machine in a shopping center. So imagine that there's a QR code pasted to the side of it. The tech comes up to it, flashes the QR code, up pops the application. Basically, you get to see the X-rays that were taken on that machine over the past 24 hours. You go select, 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 and share with, right, whether it's Lucille Packard or Shriners Burn Unit, etc. So if you can use Instagram, you can use this app. No training required whatsoever. And like I said, deployable into shopping centers. Okay. And just to remind ourselves, equally applicable in Georgia. I was using Tilden, Georgia yesterday, as opposed to Tifton, Georgia.
Yes.
Tifton, Georgia, in Tift County. Population 17,000. Yeah. You could deploy this in rural Georgia And just as a reminder, which I kind of didn't realize until a couple of days ago, if you look at the rural counties in the United States, almost 60% of them have no pediatrician, zero, not general, no specialization, just nobody, right? So our objective of phase 1 of Mercury is to deploy 50 hubs, 10 spokes per hub, and you can deploy in the US, but you can quite rapidly see that from a software perspective and deployment, you could actually go globally. You could have fixed Carter's problem quite simply, right, in this story. So you could also go global. So this is, remember, Anthony had a little girl in Myanmar. You could deploy the same application in Myanmar and allow a second opinion, which now does not have geographic boundaries, right? ER work, you're not going to fly 3,000, 6,000 miles. It's going to be nearby, right? So second opinion, on the other hand, does not have geographic boundaries. And so the ability, and we're actually spending time with Texas Children's who does second opinion. Interestingly enough, they say they do 30 of these in cardiology, just the cardiologist specialization. They do 30 of these a month, 15 in the US, curious, 15 outside the US, dominated by Latin America and the Middle East. So again, could have made a difference in the story that Anthony tells. Okay, so remember, all this is about, let me share an image with a human expert in Atlanta or in Orange County or wherever. But there are not a whole lot of human experts, right? In fact, they are increasingly geographically centralized. Let's call it in the NFL cities, right? This is actually a New York Times that was last year reported. If you dive into numbers, the US has about 3,000 pediatric cardiologists in the country. We graduate about 100 a year, even though our population grows by 4 million. If you leave the country, this gets, a whole order of magnitude more difficult, right? India has 300 pediatric cardiologists for a billion population. Rwanda has 1 cardiologist. Congenital heart disease is still the #2 cause of death of kids in Mexico. I mean, I'll use Canada. In Ontario, in Toronto, there are 50 pediatric cardiologists. If you go to Thunder Bay, there's 0. So, which leads you to going, well, shoot, AI. We could take Anthony's brains and put them into software. And so now I'm going to switch gears and talk about adult medicine because there's way more work that's occurred in adult medicine. This is actually a report that was released earlier this year. Actually, Matt Lundgren used to run the AI medicine program at Stanford. He went to the dark side, now works for Microsoft. Pranav is actually over at Harvard. And so this is an assessment of the current state of AI in medical imaging, adult medical imaging. And it's not so good. In essence, yeah, they work great on the data it was trained on, but as soon as you go to any other population, they don't really work that well. Now, why is this? Well, if you become a student of neural networks, which is really the core technology that is powering ChatGPT, Alexa, all the cool stuff we've seen on the consumer side, the cool thing about neural networks is, and this is actually, I stole from Jeff Dean, who runs Google Brain, is that it's the singular technology that if I can give it more and more and more data, I could get near linear improvements in accuracy, which is why, at least where I live, the Waymo cars are still driving around taking LiDAR pictures of everything. Because if you're going to go build autonomous driving, you've got to have tons and tons of data. So the state of the art today is that, yes, ChatGPT has access to tons of data, but in medicine, not so much. So this is actually gives you a sense of what data sources there are for adult medicine. So most of it is coming from 3 states, you could guess, New York, Massachusetts, and California. You could furthermore guess it is not coming from Willits, California. It's, San Francisco, LA, whatever. If you zoom out and look at this on a global basis, two countries provide 50% of the data. Again, not too surprising, the United States and China. As soon as you leave those two countries, there's only 8 that provide any of the data, and none of it is in Latin America, South America, Africa, Middle East, any of that, right? So because of the lack of data, right, these algorithms cannot be very accurate. But then actually there's a crap load of data. That's a technical term. Crap load of data, right? So we did a back of the envelope analysis, the Echo Lab, which is where the cardiologist works. And in all 500 children's hospitals, if you aggregated the data over just 1 year, you would get 6 million terabytes of data, which is an enormous amount of data. Now you think about, well, I could build with that kind of data, I could build accurate algorithms for a whole host of diagnostics, right? Okay, let's just play a little thought experiment. If we took the conventional approach, which is the centralized approach, this is in essence how ChatGPT is trained, Alexa, ImageNet, all this stuff has been done, is you aggregate the data in a central location. And in our little thought experiment, okay, let's go put it in Ireland, a good place. There's a data center in Ireland. Okay, you put it there, you split the data into training data sets and test data sets. You train your AI algorithm on the training data set, and when you're ready, you go set it loose on the test data set. And if it's good, you go release ChatGPT 4 or 4.5 or whatever the heck it's going to be. Okay, this is the classic way it's been done. The problem is, in medicine, this is never going to work. Let me explain why. 3 essential problems. Number one, who's going to pay the data transfer from, California to Ireland, from Bambino Gesù in Rome to Ireland? Who's going to pay the data transfer cost? Number 2, privacy. This is not privacy management. One of the central tendencies of privacy is purpose limitation. So when you aggregate a whole bunch of data, 6 million terabytes, you go, well, I'm going to do good stuff with it. That's not purpose limitation. Not to mention, you may be familiar with data residency rules, data sovereignty rules. Norway has already said, we're not letting Norwegian data leave Norway, as an example. So it's not going to, you're not going to be able to do this because of privacy management. Just to make a point of it, NIH has had a project going on, I think now it's 5 years, called Imaging Data Commons for cancer. They're at 44 whole terabytes. You take a centralized approach, it's not going to work for privacy reasons. And then the last question, which nobody answers in medicine right now, is, wow, cool, you made a great algorithm, right? Wrote a great research report. How does it help a kid in Myanmar or a kid in Willits, California? Where are you going to deploy any of this stuff? So we don't believe centralized architectures are going to work for AI in medicine. And so we are in the process of building Gemini, an AI lab for children's medicine. And it is all built on the idea of being able to do decentralized learning. So the good news here is my friends on the consumer side have been working on this. So you may not realize this, but Siri, when Apple wants to make more accurate, it could be taking your voice and sending it to the Apple cloud, right? And learn it back to the centralized model. Well, there's 2 problems with that. Number one, what about privacy? What else did I say to Siri? And number 2, who's going to pay data transfer, right? Is it going to run on my Verizon data plan? No, thank you, right? So Siri, Google Keyboard actually works this way, is learning on your phone. It's learning locally in a decentralized manner. It then takes what it has learned, which are a bunch of neural network weights, and sends it to an aggregation server. So number one, it's, hey, a lot less bandwidth, a lot less network traffic, more network preserving. It's a phrase that's often used. Second of all, right, what privacy? I'm just sending you a bunch of numbers, right? There's no image there, your voice isn't there, etc. So And then the third point we're making with people is, because of the architecture, once you've built that great FCD diagnostic algorithm using data from all the MRI imaging in all the 500 children's hospitals, you could deploy back into the network, and it will run in Tilton, Georgia, in Willits, California, in Myanmar, et cetera. So our initial plan for Gemini is to deploy 32 zones, 32 children's hospitals, all the imaging machines being twinned, which will result in about 1,600 distributed servers on a global basis. And on that, learn how it is that we use what some people will call federated learning techniques to be able to do decentralized learning on medical imaging, which would be a huge step forward in being able to actually use this technology and create accurate algorithms. And just to make a point of it, fundamentally solve focal cortical dysplasia, fairly easy to do once you realize we could have all the MRI images of every children's hospital in the world to train this on. So I'm going to end with our third. So we really kind of had three challenges. Number one was, could we build the technology? Would the technology work? We're pretty confident after having gone through the Vanguard program that the technology is fine. Obviously, we also needed the support of the children's hospitals themselves. We're putting servers into Children's of Orange County. And this is actually a poster that we brought to the Pediatrics 2040 conference earlier this year and had people sign it. That actually, if you zoomed in, you would see the Chief Operating Officer of Seattle Children's, the Chief Operating Officer of Arkansas Children's, the CEO of Children's of Orange County are all signatories on that. So we felt pretty good that we have the support of many of the children's hospitals, which has left us with the last question, which is, I've funded all of this up until now, but Mercury and Gemini, we've estimated at rough 40 million. Kind of beyond my pocketbook to be able to pull that off. So we're going, okay, how are we going to do that? Well, one answer could be, let's go to venture capital. I mean, I live in Silicon Valley, right? Let's go to venture capital. So my friends at Stanford actually are going to release a report which will show that seed capital for pediatric innovation, I know I'm sitting in these places, pediatric innovation over a 3-year period, 2019 to 2022, was a whopping total of $5.7 million. 5.7 million, which ostensibly is zero. I mean, I'm actually the chairman of an accelerator, a B2B accelerator, and one of our companies, we just raised 5.7 in a seed round with one company. So bottom line, we're not going over the venture capital. This is like a pointless exercise, right? Okay, number two, well, we could go to the children's hospitals. Well, they really don't have that much money. This is fascinating. This is actually the economics I learned at UCSF Children's, spent time with the former CEO. So when you look at their economics, okay, 60% of it is covered by Medicaid, not Medicare. 20% by insurance, which Mike said, yeah, they inflate it slightly to be able to cover some of it because Medicaid's not a very rich program. And then a whopping 20% is donations. They run the operating business on donations. So it's like, no, we're not going to show up at the children's hospital. The other point to make is, if it hadn't dawned on you, is we're building a nationwide / global network. Well, let's roll the time back. If you were going to build an internet, you couldn't have gone to Delta Airlines and said, would you like an internet? And then go to Home Depot and said, would you like an internet? It would never have worked, right? So what did happen was the United States government funded under ARPA, right, the origin of the core internet. The first 1,000 nodes were really all funded by the US government. So the first area that we have been talking to is basically government sponsorship. So some of you are familiar with the new ARPA-H as an example of this, right? But we're also talking to HHS in general, NIH, Bureau of Indian Affairs, because remember back to where's the power in all of this? If I say, if you're mom works at Google and you live in Palo Alto, none of what I talked about matters very much. It's all okay for you. But you're in Willits, California, or Tilton, Georgia. This matters. So think about that as Indian reservations across the United States is another example of a vastly underserved world, part of our world. So number one is that we've obviously opened up the front with the US government. We're opening up the conversation with the EU, obviously. And then I just started talking to the government of Singapore. So if you think about it, we're talking about a national infrastructure at the end of the day. Why shouldn't governments do this? But we're not just standing on that alone. The other major thing is we're going after corporate sponsorship. So the simple story here is my friends at Juniper Networks, they actually put a decal on a Formula One race car. And I'm talking to some of their senior people. I said, yeah, you guys probably spend $1 million to put that logo on there. And they went, actually, it's much more. And I was talking to my friends at Alteryx, who also put a decal on a Formula One car. And the number turns out it's $5 million. So I'm looking at them going, guys, you spending that kind of money to put a decal? Why not sponsor the Pediatric Moonshot? So one of the conversations we had yesterday over at TAG is I said, look, I don't see why it's not Home Depot, right, UPS, the Atlanta Falcons, et cetera. I'm going to tell you the story about AGCO because it just like stunningly opened my eyes. So AGCO, some of you may be familiar with, it's the third largest agricultural equipment manufacturer in the world. They're headquartered in Atlanta. Okay, so I've known these guys for a long time. In fact, at my Stanford class, I had their previous CEO, Martin Rischenhagen, come and do my class. So I've known these guys maybe 5, 6, 7 years. I just had their new CEO, Eric, come and do my class at the beginning of this year. So I posted about this class. So a couple of the AGCO guys who I've known for a while, they reached out and said, oh, you know, how are things going? So I met up with Matt Rushing. So Matt runs the Fent, is one of their brands. He runs the Fent group. And so we're catching up. I'm telling you what I'm working on. And I said, well, you know, AGCO could sponsor this because, well, what about all of its employees in Georgia, right? Back to why would you do this, right? For your employees, which, by the way, healthcare cost is the #1 cost of any corporation, right? And he goes, well, actually, there's a better angle here, which is our customer. And so it dawned on me. If you're in agricultural equipment, guess where your customer is? They're in all the rural counties. They're in all the rural areas of Brazil or Africa, et cetera, right? So he goes, there's such a good connection between our customer and what you're trying to do. So Matt and I are actually working on a joint proposal to AGCO management to go, why doesn't AGCO become a core sponsor of the Pediatric Moonshot? So as I said to the TAG group yesterday, anybody who's got connections into government or corporate, loving to have this conversation. So you can imagine I'm ramping up Pat Gelsinger, who's the CEO of Intel. This is actually my current, I teach this quarter. So this is all the CEOs that showed up in class, including Jenny Johnson. Actually, just to make a point of it, I have this objective that at some point I'm going to end up with 8 public company CEOs who are all women. I'm at an all-time high. So Yamini and Jenny are both women CEOs. So I'm up to 2 out of 8 or 7. So I'll end by reading a quote, which I think is just great. This is John F. Kennedy as he is talking about the original moonshot, right? And I'm just going to read it. He said, "We choose to go to the moon not because it is easy, but because it is hard, because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one that we are willing to accept, one we are unwilling to postpone, one which we intend to win." So I invite all of you to join our Pediatric Moonshot to reduce healthcare inequity, lower costs, improve patient outcomes for kids in rural Georgia and around the world. And we just released a new website, pediatricmoonshot.com. Go check it out. You can register for a newsletter there. We do a monthly update to the community about this. We're pushing, we have a Pediatric Moonshot LinkedIn page. Please go there if you go on LinkedIn and follow it. We'd like to get to 1 million followers on that page. We are developing our TikTok strategy, our Instagram strategy, etc. In the world of Spotify, we've actually just released the Pediatric Moonshot playlist. Each of the songs is one of the crew members suggested and it is on there, so it's kind of cool. We're going to release a series of podcasts. They'll be on Spotify, on Apple Music, etc. And as I said, any of you who are connected into wherever in the government or into corporate, we'd love to talk to people who can make those introductions. So I'll end by something that kind of motivated me. So I teach this class at Stanford. One of the things I say at the end to all of them is I go, you guys are the lucky ones, right? You go to school at Stanford, you're smart, you have capabilities, you have connections, right? And I said, look, to those who much is given, much is expected. And I have said this for 15 years. Well, like I said, about 3 or 4 years ago, I was going, well, what am I doing about this? So really the choice I made to come out of retirement was really based on this sentence, which is, I have been given a lot, I have lots of connections and whatnot. Why am I not using this to some good in the world? So thank you for your attention. Open for questions, both online and offline.
Yeah.
Go.
I had a question. So I was looking at, I think it was Pediatric or Program Gemini rather, and I wanted to know, is this data available to, let's say, startups who want to try to use the data, or how exactly can we use this data?
Yeah, so Gemini, we are in the process of building Gemini, which will have, as we said, 32 sites, et cetera. We're going to start in cardiology, so it's going to be ultrasound machines. We're going to actually start with an application, which is a convolutional neural network to manage or to determine what's called ejection fraction. Not because it's particularly clinically relevant, but it's something we can all agree on fairly rapidly about whether it's correct or not. And so it's all designed to figure out, can we develop, what are the stacks? There are multiple federated learning stacks out there if you're following this, coming from people like Intel, OpenFL, NVIDIA's got Flare, all of this. There are a bunch of startups out there, FedML out of USC, Dynamo out of MIT. So which of these, we're actually starting to work with, it's kind of cool, a bunch of guys who left the Siri program at Apple. And we're starting to work with them because obviously I use Siri as an example of this. So really what we're doing in the lab is focused on what stacks, what's the federated learning pipeline going to look like, et cetera, in that environment, as opposed to the general statement of we're just going to open it up. Because back to, if you're focused on privacy management, you have to have a purpose. So why is Children's of Orange County going to share this data? I just explained it. It's going to be because we're going to measure ejection fraction. We're going to perfect, right, the fine art of how federated learning looks. And each step along the way, we will invite, so we're already working with a couple of ISVs, what we call ISVs, to be able to take their technology and have them build edge cloud applications. So, yeah, but the general idea of just opening it up and saying, here's all the data, no, we're not going to do that. Yeah. Does that make sense?
Yeah, it does. And I guess I was also wondering about Program Mercury, since this is an image sharing network. So your goal is primarily to share among pediatricians and not necessarily with researchers, is that correct?
No, Mercury is focused on image sharing between non-children's hospitals in Willits, California, or whatever, and experts at children's hospitals at UCSF. So it's merely to allow, Instagram to work, except it's medical imaging, and have an expert opine on that image, okay? Gemini is all about how do we use image data to create AI applications that could, in the example I talked about, be able to diagnose focal cortical dysplasia using MRI imaging. So that's really the two major areas we're working in, is image sharing, simple image sharing for purposes of emergency medicine, which is the example I gave, as well as second opinion. So those are two big application, back to application areas. The technology kind of graph is hugely broad about what could happen here. But we, just like with Apple, we said we're not going to just open it. It would make no sense just to open it up tomorrow. Let's show people what it can do in two big areas. And then, right, we will say, we will open the world. We've created Double Cloud Studio, probably not too surprising, to allow people to gain access to the APIs, build apps that deploy on here. But while we have that, we're not making a major push to open that up until we get the rest of this, you know, Mercury and Gemini launched.
Any other questions?
I have a question. Why are you here today?
Me?
Oh, we can start with you.
Yeah, I was interested in, so I do research in an AI lab, and so I'm interested in potentially using AI because I eventually want to go into startups and I see like a great, I guess, opportunity to use AI to expand healthcare to marginalized populations. I wanted to learn more about that.
Yeah, and I would tell you, go become a student of the whole federated learning world, because I just don't believe it's going to happen any other way. And it's very early days of this stuff. Even federated learning itself is maybe 3 or 4 years old, even for consumer apps. So it's very nascent. And I would just tell you, go spend time on the tech side on that, because that's going to be the trick, I believe, figuring that out, how you decentrally learn, which is a whole different game than what everybody's been doing up until now. Here, I'm going to go over here in the back.
Hi. I work in a DME lab here, designing patient-specific medical devices. And when we have to get patient scans, we do have to go over to Children's and actually get a CD and drive it back here. So, you know, this whole area is clearly of interest to me, and we're hoping to make that whole process a lot easier for everybody.
Yeah, we agree. I mean, 100 times over, we agree. It's crazy how primitive it is right now.
I work for the Pediatric Technology Center, and I'm one of the organizers.
Ah.
Yeah, this one helps us out a lot.
Ah.
But it's always good for him to learn about the things that we do and are interested in.
Right, I use ChatGPT a lot because I find it real hard to kind of, get some content together sometimes. So that helps a lot. So.
Oh yeah. Well, and that part of the world's just begun.
Yeah.
Yeah. Yeah, it was not too unobvious. We've been mostly focused on image data, not text data. But there's a lot of reasons that we're going to play with text data as well. And yeah, large language models have huge implications over there. Do you have a question?
Oh, no.
Why are you here other than Lori made you come?
No, this was really interesting. Especially my husband is a stroke survivor. So when we were talking about imaging, I just clearly remember images having to get from the hospital he was initially taken to over to Emory before, I authorized them doing surgery, and then showing me before and after images from the surgery. So, I was just like, wow, what if, if this was in place and it would have been quicker, or how does this impact, future stroke survivors and things like that. So this is all interesting, not pediatric related, but the imaging portion of it and sharing that information quicker was interesting.
Yeah, yeah. Well, a lot of people say, why are you guys doing pediatrics? Because none of the technology actually knows whether it's in a pediatric hospital or an adult hospital, right? And in fact, when you look at Mercury, what I'm really saying is the edge servers are going to be in non-children's hospitals, right? So we know there's a, you know, the linkage is there. But when you're a young company, you don't want a lot of things to focus on. Pediatrics, the other thing is an advantage in pediatrics is almost by definition, they have to work together. Because there's no giant, you know, like Intermountain Healthcare, Kaiser, these, well, I guess Wellstar here, right? These big, you know, those big networks, they will tend to say, we can solve this problem because, you know, they own lots of stuff and resources. But when you talk about pediatric medicine, with the small exception of Shriners, there are no networks, right? It's Lurie's in Chicago or Texas Children's. And so the idea of networks and sharing is almost implicit in their world. And to tell you the truth, once you hear these stories, you're like, we can fix this problem. This is not that hard. Right? And, you know, if kids are taken care of, they just grow up to be adults. Right. So,
Any other questions? Thank you.
okay. Thank you.
Awesome.
Yeah, go to LinkedIn and follow us.
Yeah.
That's my big ask. And go to Spotify and download the playlist, or download, whatever, listen to the playlist. It'll be fun.
Did you have my song?
Which one was yours?
Drops of Jupiter.
It might have gotten at it. You have to go look.